Hi everyone, welcome to another class of MBA CAT Fastest. This is Shubham Jaiswal and we will be continuing our series of videos, concept overviews with another topic remained as very important from the exam's perspective and point of view. So what we have learned in our childhood, we will begin from there. 7, any number or dividend which when divided by divisor, whatever is left which cannot be divided is remainder. Now let's say we already can easily see 728 when divided by 5, 3 will be left and it will be the remainder. Moving on to advanced level, I would like to tell you if 728 can be written as a product of three numbers, which it is 7 into multiplied by 8 multiplied by 13, could have also obtained the same results when each individual of this 7 when divided by 5 will give a remainder of 2, 8 when divided by 5 will give a remainder of 3, and 13 individually when divided by 5 would yield a remainder of 3. The product of all those three becomes 18 by 5 and it will give a remainder of 3. You could have also done this. This becomes easy when this divisor is of great value in where finding quotient becomes troublesome. So this method is easier for the bigger numbers. You could have also obtained the same result if I would have written 728 as 700 plus 24 plus 4. The remainder would still come 3, and or you could have obtained the same if you would have written 729 minus 1 by 5. The remainder would still come 3. The point is in exam you can change the number as per your convenience, whichever would deem easy to you, and you could obtain the result. The answer would always remain same. Right? Okay. If using negative remainder, always convert to positive. See, now what is a negative remainder? Negative remainder for this question example, the remainder here is 3 and the divisor is 5. So when the remainder is subtracted by divisor, here in this case 5 minus 3, it will become 2. Right. So this is your negative remainder. Means whatever is ahead. Although this is completely abstract, no questions will be asked on negative remainder, but we use this negative remainder as our convenience to solve and to get to positive remainder. The ultimate goal is to reach here only. Okay, this is not the ultimate goal. Okay. If numerator is smaller than denominator, then it's the remainder. 2 when divided by 5 will give the answer 2 only. For higher powers in numerators, first we try if numerator can be converted in a form such that it could give remainder plus 1 or minus 1. Now just imagine, had instead of this 2, 3 and 3, it could have been 1, 1, 1 raised to 100 times. You would have easily said that the answer is 1, or which means the remainder would be 1. So that is what is written over here. We first try to see if the number can be converted in the form of plus 1 or minus 1 as a remainder. Yes. उसके बाद cancellation factor. See, if you have cancelled numerator or denominator with a factor before reaching the answer, you will need to multiply. This I am highlighting this again. We tend to forget that factor back to the remainder of 10. Let's say this 728 is not a multiple of 5, but we were supposed to find the remainder of this number. So if you cancelize this, then at the end you will need to multiply this 5 back, whatever is the remainder of 10. Now, Euler number. What is a Euler number? Euler number is the total number of numbers which are available before n and which are co-primes to n. This is the formula for it. If n is made up of 3 prime numbers, if it is made up for 2 prime numbers, then you will need to remove this. If it is just made of 1 prime number, or if it is made for more than it, you can extend this formula. Okay. Now, if you wish to find Euler numbers before n which are not multiple of p1 only, let's say you wanted to find the total number of numbers which are before 24 and are not multiple of 2. What we will need to do, you will need to replace n with 24, and you will need to replace this p1 by 2. Whatever the answer you will get it the number of n which are co-prime to 24 and which are before 24. Now, Euler theorem in remainder. By now, you would have sensed it is basically for power, how to diminish the power. If a number is written in the form of x to the power a, and which when divided by b, how you can reduce it? You can solve it individually as well. by taking this x by b as 1, where and then for another this is power a by eb, and here it is, this is Euler number eb. Let's say the base is 37. So what is the Euler of 37? It will be 36, and this will become, for 37, Euler 37 will be 37 1 minus 36 upon 1 minus 1 upon 37. This will yield your result 36. So this. Now if you wanted to find out, so you just need to put Euler number. This will diminish the power. If the power is, let's say, 72, a is equal to 72 in over here. So when 72 will divided by 36, it will yield a remainder of 0, right? So this has already diminished a lot of power, and a lot of your work has been made easier. So you can use Euler theorem in that context. And of course, I forgot to tell this, but always remember this: these two are to be co-primed to apply Euler. Okay? This is a very important condition to be remembered. Now, splitting denominator. Now, splitting denominator and Euler theorem both are for solving powers of numerator generally. But at some places, Euler becomes lengthy, so we use splitting denominator as an alternative options. After splitting denominator, you can use Euler's. Now I am going to tell you what is a splitting denominator. If x is to be divided by p, which can be written as a into p, this also has to be a co-prime number. Okay. Either it is a complete power of one prime number, it is a complete power of another prime number. This condition has to be met compulsorily to avoid to use a splitting denominator. Remember, in Euler, these two are to be co-prime. In the splitting denominator, these two are to be co-prime. After you have identified which two number are to be taken as product of this p, you need to form a number which, when divided by a, leaves the remainder of x by a, this part, and then you need to find, and when divided by b, p leaves the remainder of x by b. So after you have formulated, you will get a number. This, when divided, if the number is less than p, that is your answer. If it is greater than p, then you need to divide by p, and that will be your remainder left. Okay, fine. Reverse Euler theorem is again preferably for power it is used. It is used when the power is just less than Euler number of denominator. Solve it. For example, we have seen Euler of 37 is 36. Now if the power comes to be 34, x to the power 34, which when divided by 37. So what will happen? Your purpose of applying Euler theorem is not solved, because for Euler theorem this is 36, right? So if you, even if you solve here x by 37, you can find remainder of this, and another, the Euler 34 when divided by Euler of 37, this will give 36. So you still have a remainder of 34. What you will need to do, you will need to solve it similarly like how you were supposed to solve in Euler, but just increase the power of x. Consider the quotient to be x to the power 36 and remainder. And when you are done doing this, while you are doing this, you take x to the power 34 as one number, x square as another number, solve it like this, and you will have your answers for the lot easier, right? Okay. Now, key points to be used while solving the remainder questions. First one is, if power in numerator means could be solved by either Euler or splitting, any one of the method you would be using. If splitting not possible, means Euler is to be used. Let me explain what myself again what I am trying to say here. Let's say x by 36 is there and raised to the power of 36. Now, then you know this could easily be solved by Euler 36. Here individually you divide x by 36, and Euler of 36 would be some value which will be definitely lesser than 36. So power will be diminished. Now if it would have not been possible, of let the power would have been 37 or something other number. If it is not possible, you would have split this in the number of form 9 into 4, and you could have easily solved by splitting denominator process. If the power is just less than Euler, then reverse Euler is to be used. which I have explained here how it is to be used. Now, Wilson's theorem in remainder. This is particularly used for factorials only and factorials of a prime number. So let's say you get a question of 36 factorial divided by 37. You could directly write an answer that it will be -1. If you get another question, 35 factorial when divided by 37 factorial, you will directly write the answer +1. See how easy the calculation it had been made. And if you get another question, 34 factorial, which when divided by 37, you could write the answer to be 18. If any further questions comes, if 33 factorial, 32 factorial, how you could solve the same thing as we have used reverse Euler theorem, which I have explained here over here. Right? Okay. Moving ahead. Um, let's continue this topic in the next video. I hope the learning helps you, and thanks for watching.